This is the continuation of the HCF and LCM video. Still about HCF and LCM, yeah, but with real life applications. So what's that about? Let's take a look at an example. The lights on three light shapes flash at regular intervals. The first light flashes every 18 seconds, the second every 30 seconds, and the third every 40 seconds. The three light flash together at 10 p.m. At what time will they next flash together? Okay. So, um, if you encounter a question like this, yeah, says like, oh, every how many minutes or how many seconds or how many hour or how many days, blah 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 blah. When will they blah 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 together? Something like that. It'll be always LCM. Why? Mm, I'm gonna tell you later. Yeah. So let's just go directly to the solution first. So this one skips directly to the prime factorization. Okay. Yeah, because sometimes when you already get used to question like this, you already get used to doing factor tree. Sometimes you're you don't need to do the factor tree on the paper. You can just do it mentally. Yeah, you know what I'm talking about. When you do it mentally, you can just write down the prime factorization immediately. Yeah, that can happen if you practice enough. Okay, so yeah, so I understand why the book doesn't provide you with factor tree or something else, just directly to prime factorization. It's okay. It's allowed. Okay, it's legal. Don't worry. Okay. Do we need to check the prime factorization? Okay, just keep it here. You can check it by yourself. Jump directly to LCM. So take the bigger one of all. So 2 to the power of 3. 3 to the power of 2, we take it also, even though 40 doesn't have 3, because in LCM, we just take whatever they have. Yeah. Each of their kind, all we take. 5, 5 also we take. So multiply, the product will be 360 seconds, which you divide by 60 become minutes, right? So 6 minutes. Okay. So three lights will next flash together at 10:06 p.m. because it was 10 p.m. and then the next time they flash together is 6 minutes later. Okay. So earlier I was gonna tell you about why this kind of question needs you to find the LCM, not the HCF. Because in the HCF, the answer will be a very small amount, really small like this. So it'll be illogical, if you understand what I'm saying. Yeah. While it's more logical if you find the LCM because it's the multiples of these numbers, right? Because we need to find, you know, the time after this time, right? So it'll be the multiples of them. Okay. So not possible if HCF. Practice now. Bells told together at blah blah blah. Yeah, this time, yeah, this one is also LCM. Really obvious. Okay. Now let's go to number 2. Farhan has 3 pieces of rope with lengths of blah blah blah. He wishes to cut all the 3 pieces of ropes into small pieces of equal lengths such that there are no leftover rope. What's the greatest possible length of each of the smallest pieces of rope? Okay, yeah, you've been hearing me reading the question for too long. Okay, but the point is, let me just make an simple illustration. Okay, These are the three pieces of rope. Now, he wishes to cut all three pieces, so we cut them into smaller pieces of equal length. Mhm. Equal length. So just, you know, for example, maybe like this. Uh-huh. This. Remember, equal length. So the length of each smaller pieces must be the same. Now, what is the greatest possible length of each of the small pieces? Now, to make you understand this more, I'm gonna make another more simple, yeah, example. Let's say this is 4 centimeter and this is 6 centimeter rope. I'm gonna try to cut it into yeah, small pieces, yeah, smaller equal length of pieces. So 4. So I can cut this to, well, this is not sorry, this is not really accurate of drawing this. Yeah, I think this is more accurate. So the greatest possible length that I can make, yeah, by cutting these two in small pieces is like this. Makes sense? Because it's 4, it's 6. Uh, why did I say this simple? This example is more simple, and you can more understand because you learn in the primary school using the units, right? So let's call it 2 units. Is it 1, 2? And each unit is 2 centimeter. Am I right? For 6, it is 3 units. With 1 unit is also 2 centimeter because we agree that we want to cut it into equal length, right? Okay, 2 and 3 units. Now, if we want to find the length of the rope, how do we do it? We already have it, 2 centimeter, the same right now. How do we get these two from HCF and LCM? Can we? Let's try to do the factor 3 first. 4, 6, 2, 2, 2, 3. So 4 is 2 to the power of 2. 6 is 2 times 3, right? So HCF or LCM? LCM. Which one? Now, the answer is HCF because HCF we just take 2, right? 2 to the power of 1, smaller one, and we don't take 3. While in LCM, we take 2 to the power of 2 and 3 become 12. 12 is bigger than this, yeah? It's logical because it's the multiples. We want to find the HCF, which is 2. So the same thing with this. If you want to find the greatest possible length, you know the answer already, right? HCF. So LCM, HCF. That's it. So if you're talking about real life application of HCF and LCM, they can make the question like whatever they want. They it can be so like creatively so many questions. The variety is limitless. So we cannot I cannot provide you all the examples. I just can like teach you the concept, the thinking concept of this. Once you get the thinking concept of this, whatever question you encounter, you will more likely to be able to solve it because you will be able to determine immediately whether you to use LCM or HCF. Okay, all right, and then finally, it's review exercise 1 and challenge yourself. It on page 24 and 25. that means that's the last of the chapter. So HCF and LCM done. I'll see you on the next video. Yeah, talking about another topic. Bye bye.